Evaluate the integral from 0 to 1 of x to the 10th plus 10 to the x dx. Now this is a definite integral because we have limits of integration. And if the function is continuous on the interval from 0 to 1, that means that we can apply the fundamental theorem of calculus part 2, which makes our lives easier. X to the 10th is a power function that is continuous everywhere. And 10 to the x is an exponential function that is also continuous everywhere. So their sum is going to be continuous, and that means that we can apply the fundamental theorem of calculus part 2. So all we need to do is get the antiderivative, or the indefinite integral, and evaluate it at those limits and subtract. Now we already know what the indefinite integral is because that's what we did in the last video. So this is going to be x to the 11th over 11 plus 10 to the x over ln of 10. We can drop the constant because it's going to cancel when we evaluate this at 0 and 1 and subtract. So let's plug in 0 and 1. We start with 1 to the 11th over 11 plus 10 to the 1st over ln of 10. And then minus, we plug in 0 to the 11th over 11 plus 10 to the 0 over ln of 10. Now, 1 to the 11th is 1, so that's going to be 1/11th. And then 10 to the 1st is 10, so that's 10 over ln of 10. Minus, that's going to become 0/11ths plus 1 over ln of 10. And when we subtract, 1/11th minus 0/11ths still gives us 1/11th. And then 10 over ln of 10 minus 1 over ln of 10 gives us 9 over ln of 10. And this ends up being our final answer.